Let me introduce myself. I am Dr. Verma from the Indian Institute of Technology, Kanpur. I am an assistant professor of psychology in the Department of Humanities and Social Sciences and also part of the interdisciplinary program in cognitive science at the institute. Now, this is the fourth in the series of courses relevant to cognitive science that I have offered on NPTEL. The title of this course is Introduction to Brain and Behavior. Now, as you know, one of the central tenets in cognitive sciences is to make a connection between the mental processes and some of the other peripherals, like how the brain is basically involved in carrying out or in manifesting those mental processes. We have talked in detail about these mental processes in the two courses that I have offered earlier, Introduction to Basic Cognitive Processes and Introduction to Advanced Cognitive Processes. In this course, what I will be trying to do is I will be trying to make connections between the mental processes like learning, memory, attention, language, thinking, decision making, etc., and study them from the perspective of how these mental processes manifest themselves in the brain. We will talk in a lot of detail about the nature of the mental processes, just to remind you of some of those things as we've discussed about them earlier, but the emphasis will be on how these mental processes are manifested in the brain in terms of whether they are localized to certain areas or certain parts of the brain, or they are manifested by a network or a set of areas that are interconnected with each other and work together to bring about significant mental processes, like say for example memory. Okay, so for example, one of the crucial things in this course we might be studying is the fact that how does attention work. Say for example, which are the areas in the brain that work together to control say for example our attention to specific stimuli. Similarly, we will be looking at other cognitive functions, say for example which areas of the brain are relevant to language. We all know from the last course that language is predominant, language production basically is predominantly held by is predominantly manifested in the left hemisphere of the brain, more specifically in the left inferior motor areas, say inferior frontal areas where the primary motor cortex is. So basically we will be trying to make a lot of these connections and study how the brain or different parts of the brain come together to manifest these different mental functions. More about this in detail when we start the course. Let me give you a brief outline of how the course will run. We will start with an introductory lecture into the topic of cognitive neuroscience, which is basically what this course is going to be about. So the title of the course is Introduction to Brain and Behavior, which also you can take as an introduction to cognitive neuroscience course. Okay, so this is basically an introduction to neuroscience course, introduction to cognitive neuroscience course. Now, to begin with, let me also differentiate between neuroscience and cognitive neuroscience. Now, cognitive neuroscience is a special branch in neuroscience in general, which is more focused on the neuroscience of cognitive functions, which is more focused on, as I have been saying earlier, how the areas of the brain, different areas of the brain, different patterns of connectivity in the brain lead to or manifest in carrying out different cognitive functions, mental processes, that is. Okay, so we'll begin with a beginning lecture on introduction to cognitive neuroscience, how it is an important field to study, what is it, what is its importance in relation to other subjects, other areas of cognitive sciences, and what important information does it add to, say for example, if you want to develop a theory of how the human brain functions. We'll begin then with talking a little bit about the methods used in cognitive neuroscience. What are the methods that are used to study the brain? See, I have mentioned that earlier as well, and just to and for some of you who might be taking such a course for the first time, basically it is very important to study the brain in its normal conditions. Say for example, one of the aspects of or one of the key differences between studying a machine versus studying the human brain is that you can at some point, if need be, take apart the machine and build it back together in order to really understand what each of the components of that machine are built of, how they are connected, and how do they lead to particular functions. You cannot do that so much with the brain. Okay, so typically the study of the brain involves two kinds of methodologies. One is the study of disordered or damaged brains, which is done under cognitive neuropsychology, and wherein basically we study the brain, we study the mental functions and the brain connectivity of patients who have some kind of damage to the brain. It might be due to some disease or congenitally acquired, or due to some injury or accident, etc. That part basically is more covered in cognitive neuropsychology. We will also be talking about, by the way, injured and damaged brains in this course as well. But the focus or the emphasis of how we approach the brain in the current course will be more towards studying the normal intact human brain. Now, how do you study the intact human brain? You know, you cannot really say, for example, get inside the brain, literally speaking, and see where a particular stimulus is being processed and how, say for example, particular responses are being generated. But you can, say for example, study some of the different activities, different patterns that go on while the brain is processing particular stimuli. Sophisticated methodologies have been developed to study this aspect of the functioning human brain, and we will talk in a lot of detail about some of these neuroimaging techniques like the PET and the functional MRI, and and different kind, and maybe Doppler, and some of the other techniques. We will also at points be looking at the temporal resolution of mental activity. So we will also be talking about EEG, ERP, and some of the other methods. Okay, so we will begin with stressing about what cognitive neuroscience is and how is it connected to other parts of neuroscience, other parts of cognitive science, what are the stress areas, and then we will talk a little bit about the methods that are used, that are generally going to be used in cognitive neuroscience. Moving on, we will start talking about particular mental functions and how the different areas of the brain come together to lead to the successful operation of that mental function in mostly normal individuals, but in some cases in individuals with some kinds of brain injury or disease as well. So we will start with attention, perception, memory, learning, and so many other things. So this is a little bit about the content of the course. The structure of the course will be that, as you know, this is going to be a 20-hour course, which is basically 8 weeks of lectures. At every week you will have 5 lectures of about 25 to 30 minutes. At the end of the week, after the 5 lectures, you will receive an assignment, which will be basically MCQs based on whatever we have covered in that week. You have to do these weekly assignments regularly and diligently, because that will give you two things. One, it will basically be a check on how much you have learned during the course. Also, it will the evaluation of these assignments will be added towards your overall evaluation at the end, if you so choose to give the examination. The course will be, as I said, 8 weeks of lectures, 5 lectures every week. At the end of every 5 lectures, you will get an assignment. You will have to do that assignment. In the end, I will encourage you to give the examination so that you can get the certificate for this course, and this is going to be a relevant course for you. I am sure you will be really interested in the course. So at the end of this, you will basically be asked to give the examination. The examination usually consists of multiple choice questions. We will talk about that towards the end of the course as well. Now, if you ask me, to whom this course is most relevant, I could begin with a very generic statement saying that anybody who is interested in knowing how the brain functions and how the brain kind of brings about your mental processes and your life, and and everything you, say for example, do, from very simple things to I want to eat an ice cream, what are the areas in the brain that are leading me to this thought and also will help me take actions to achieve an ice cream to eat at this point. To more things like, say for example, how do we store information in our brain, what is the physical manifestation of memory look like, where do you, is it like a computer software that there is a particular device, a chip which stores the memory, or does it work slightly differently in the human brain? So we will be talking about some of these things in detail. So anybody who is interested in understanding how the brain functions, I would strongly recommend you to take this course, go through all of these lectures, and preferably give the examination, do the assignments nicely so that you get a good grip of the course. This course will be useful to all students of psychology. This course will be useful to all students of cognitive science. This course will also be useful to people, say for example, in various fields like computer sciences, electrical engineering, who are constantly trying to make devices which interact with the human brain. Things like the brain computer interface based devices and so on. This will be a very good primer into how the different functions are specified in the brain, what are the areas, in what way do they function, in what way do they connect with each other. And in that sense, if you are, say for example, a computer scientist looking to build sophisticated neural networks, you might benefit from taking this course. If you are an electrical engineer focused at say for example understanding how to make some kind of brain computer interface devices, you might also benefit at this course. Industry people, say for example, who are interested in, say for example, knowing more about how the human brain works, knowing more about what this understanding can lead to, how can you use this understanding, or how does this understanding translate to actually designing better products and so on, will also benefit from taking this course. So this is basically a brief idea of what we are going to do in this course. We will start very soon with the first lecture, wherein I will detail you a little bit about what cognitive neuroscience is, as I said earlier. I hope that a lot of you will be interested in taking this course. Anybody who is interested in understanding the brain, and as somebody told me in my student days, that the brain is probably the most sophisticated, or let us say complicated machine that probably exists on the planet Earth. And anybody who is interested in any kinds of machine and how the machines work might just drop by, listen to a few lectures, and make sense of how important of a machine the brain, the human brain is. So with this, I'll try and wrap up. I hope to see more and more of you taking the course, attending the lectures, and in some sense, I would also encourage you to to make this a more interactive course, in a sense that you can write to me at my email address at arkvarma@iitk.ac.in, and I'll be more than eager to reply to all your queries and emails, and we can have, in that sense, a very interactive course. Thank you.